Hi, let's look at this question together. The number of students in school A is 50% more than the number of students in school B. The number of boys in school A is 125% more than the number of boys in school B. The number of girls in school A is 20% more than the number of girls in school B. Find the fraction of the students in school B who are girls. Okay, there's a lot of information that's given in this question. Let's write down whatever we know. Okay, first thing he says that the number of students in school A is 50% more than the number of students in school B. So if the number of students in school B is 100%, then the number of students in school A must be 150%. Okay. Second thing, the number of boys in school A is 125% more than the number of boys in school B. Okay, so if we put boy here and we say school A and school B, if school B is 100%, okay, school A has to be 225%. Okay, I think a lot of students will make the mistake of putting it as 125% because they see 125% here, but remember it's 125% more than the number of boys in school B. So if number of boys in school B is 100%, it has to be 225%. So this is a likelihood that the mistake will be made. You can simplify it. I divide by 25, I get 4. I divide by 25, I get 9. Similarly, for girls, the number of girls in school A is 20% more than the number of girls in school B. So if the number of girls in school B is 100%, school A is 120%. So remember it's 120% and not 20%. Okay. Same thing, I simplify it by divide by 2, I get 5, divide by 2, I get 6. Okay. So with this information, now I can draw the model. So I got 9 boys. Okay, I use male and female, M and F, to represent boys and girls, because if I use B, then you'll be confused with school B and school A. Okay, so male and female. So I got 9 unit and 6 unit of female. For school B is 4 unit of male and 5 unit of female. Of course, if you are doing it for your exam, you don't have to draw so many small square. You can simply put 9M, 6F, 4M, and 5F. The reason I do it is because I want to show you how I actually do the adjustment. Okay, so after you draw this model, straight away you realize that this is 150%, this is 100%. Okay, which is indicate here 100%. So if I move some of this male over to this side, okay, I rearrange it such that this is exactly the same. That means whatever left over here must be due to 50%. Okay, so I repeat, if I shift everything to one side to make these two exactly the same, whatever left over here must contribute 50%. Okay, so now I say 50% is equal to 1 male plus 1 female plus 5 male. Okay, so if it's 100%, simply times 2. So 2 female plus 10 male. Okay, but we also know that 100% is also equal to this. Okay, so it's equal to 4 male and 5 female. 4 male and 5 female. So if we compare these 200% together, so 2F plus 10M is equal to 5F plus 4M. We move it to one side, I can get 6M is equal to 3F. Okay, so which means that M is equal to 3 over 6 of F, or half of F. So every M here is equal to half of F. Okay, so now in school B, the total number of students will be is equal to 4M plus 5F. Remember, 4M plus 5F, 4M plus 5F. So 4 times half of F, because M is half of F plus 5F. So 4 times half is 2, 2 plus 5 is 7. Okay, so 7. Okay, total number of students in school B is 7 unit, and the fraction of students in school B who are girls. Okay, 1, 2, 3, 4, 5. There's 5F. So 5 over 7. So the answer is 5/7. Hope that helps.